The Mathemagical Mr. Daycott here, and today I'm going to be teaching you about the inverse versions of those hyperbolic functions. So our hyperbolic functions, as a reminder, were cosh of x, or possibly a, equals e to the x plus e to the minus x all over 2. Sine of x will be equal to e to the x minus e to the minus x all over 2, and tan of x will be equal to sine of x divided by cosh of x, which gives us e to the x minus e to the minus x over e to the x plus e to the minus x. Okay, but what about the inverse versions of these? Well, if we've got y equals cosh of x, then to find the inverse, we have to swap the x and the y and deal with it as x equals cosh of y. And using our rule as above, we end up with x equals to e to the minus, sorry, not minus there, e to the y plus e to the minus y all over 2. And that's our definition, and we have to rearrange now to find the actual inverse function for y. And so, first thing first, of course, I'm going to multiply by 2. But 2x is equal to e to the y plus e to the minus y. And from this point, it actually gets, the trick here is not so easy to see. It is a bit of a pain, but it's actually not too bad when you see it. We want to get rid of this minus e to the minus y. That's mostly the thing that's in our way. So what I'm going to do is multiply both sides by e to the y. And that will give us 2x e to the y is equal to e to the 2y, because I've got another one there, and e to the minus y multiplied by e to the y is e to the 0, so in fact it's just 1. That's because e to the minus y times by e to the y equals e to the 0, which is 1. And now I'm going to shift everything across to one side, so we're going to end up with 0 is equal to e to the 2y minus 2x e to the y, and then plus 1 on the end. Okay, now how does this help us? Well, it helps us when I make this substitution. I'm going to make the substitution of u equals e to the y. And that will rewrite this as 0 equals u squared minus 2x times by u plus 1. And if you notice, this is now a quadratic in u. And we can use our quadratic formula, where it gives us u will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, just with a being equal to 1, because our u squared is just 1, b being equal to minus 2x, and c being equal to 1. And if we plug that in, we can see what we get, and we'll end up with u being equal to 2x plus or minus the square root of 2x squared, so 4x squared, minus 4 all over 2. simplifying this a little bit, that gives us u is going to be equal to, well, 2x divided by 2 is just x, and 4x squared minus 4 divided by 2, given that's in a square root, gives us plus or minus the square root of x squared minus 1. And so we've got u is equal to x plus or minus the square root of x squared minus 1. Okay, so what does that mean for our actual solution? Well, we now need to remember that we said u was equal to e to the y. So I'm going to plug that back in, and we get e to the y is equal to x plus or minus the square root of x squared minus 1. And this here tells us that we can very, very easily rearrange for y by taking the natural log of both sides. And we'll end up with y is equal to the natural log of x plus or minus the square root of x squared minus 1. And so this is our inverse function. If we have cosh of x, or y there, cosh of x equals y, then our inverse cosh, in fact, let me rewrite that. If we have f of x equals cosh of x, then f inverse of x is going to be equal to the natural log of x plus or minus the square root of x squared minus 1. But what do we call that? If you remember, when we've got cos of x, the inverse is considered arc cos of x. So what do we call this? Well, it's very similar, but not quite the same. Rather than arc, it's called r cosh of x. And the difference between that arc and that r will be something I explain in a future video. Thank you very much for watching, and I will see you in the next video.